Today we are here at Birmingham City University demonstrating TecQuipment's balancing of reciprocating masses experiment, which is part of the theory of machines range. It's a four-cylinder engine that shows the primary and secondary forces and moments when balancing reciprocating masses and allows students to experiment with how to balance these variables. It's particularly well suited to teaching the limitations and advantages between single-cylinder, two-cylinder and four-cylinder engines. Many modern machines use some form of reciprocating, i.e. up and down or in and out motion. These usually turn it into circular motion or alternatively turn circular motion into reciprocating motion. On the downside, reciprocating motion causes unwanted vibrations and forces. These vibrations and forces can cause noise and damage, a factor that needs to be considered in engine design. The normal method of dealing with the harmful vibrations is to add extra fixed mass to lower or damp the resonant frequency of the vibrations, or add a moving mass in opposition to the moving parts in order to balance the machine. Now let's take a look around the balancing of reciprocating masses experiments. You can see two separate units. Over here we have the four-cylinder engine, and to the side is a separate control and instrumentation unit. The model four-cylinder engine is attached to a robust support pillar that fixes to a strong heavy bench or table in your lab. The pillar holds the cantilever that holds the model four-cylinder combustion engine that is driven by an electrical variable speed motor. On the cantilevers, there are a series of strain gauges that connect to the separate control and instrumentation unit to measure the forces and moments of the engine as it vibrates. This is a crankshaft that runs through the middle with connecting rods, bushings that act as big end bearings and four inline pistons that connect to the cylinder block at the top here. The three adjustable sections in the crankshaft allow students to rotate each section relative to the others to change the crank angles. For example, you can set all four pistons to move up and down together, or two pistons to move up while the other two move down. Zooming in, you can see each piston has a tapped hole. This is here to allow students to add weights to vary its mass. A clear guard covers each side of the engine, so you can see the engine's moving parts in safety. This has an interlock that disconnects the power to the motor when you open the guard. The control and instrumentation unit controls the motor that sits below the engine and takes the readings from a sensor that are mounted at the end of the crankshaft. These measure and display the engine speed in revolutions per minute. The control box also handles sensors on the mounting bar to measure the forces and moments from the engine. The VDAS onboard hardware allows students to view the real-time force and moment data on an oscilloscope-style display on a suitable computer. Using the high-speed data capture, students can investigate the resonance characteristics of various engine configurations at different speeds, and recorded data can be saved for further charting and analysis. For more information about the balancing of reciprocating masses experiment, click on the link in the description box below. And why not watch some more of TecQuipment's videos on the theory of machines? Don't forget to like, comment and subscribe. Thank you for watching.